Hello and welcome to our next episode of Ask the SOO. Starting to get pretty warm out there, which means summertime, barbecues, and the beach. Unfortunately, it also means hurricane season. So we're going to play a little fact or fiction today. We're going to talk about what's fact and what's fiction when it comes to storm surge. Okay, here's our first statement, fact or fiction. All storm surge forecasts from the National Weather Service are relative to mean sea level. That is fiction, and let me show you in a schematic why. In this example, you can see mean sea level, the white line on the bottom. Now let's say that your hurricane is making landfall at near high tide, like Hugo, so you have a 2-foot normal high tide. Now let's add the storm surge, in this example 15 feet, on top of that. You get a total storm tide of 17 feet, so you have several different numbers. Well, what we do in the Weather Service is get rid of all these different units and datums and just give you a forecast in terms of inundation or above ground level, so you know how much water will be at your specific location. Now, the inundation by itself isn't even the whole story. You've got very strong winds that build up large breaking waves on top of the inundation. So, especially in places like the Barrier Island, damage is actually worse than the storm surge alone would indicate. Starting this year, we're going to be issuing experimental inundation graphics whenever a hurricane watch or warning is in effect for a given area. These maps will show the potential of storm surge flooding ranging from 0 to 3 feet in the blue to greater than 9 feet in the red. Now, this won't be an exact forecast, but it will give a forecast to allow necessary preparations and evacuations to take place in advance of an oncoming hurricane. Next statement. The highest recorded storm tide from a hurricane on the east coast of the United States was in South Carolina. This is a fact, and it was from Hurricane Hugo in 1989. You can see the areas along the South Carolina coastline just north of Charleston had tremendous inundation, with a maximum value in the Bulls Bay area of 19.3 feet. Let's move on to a question about the strength of a storm. The higher the category of hurricane on the Saffir-Simpson scale, the larger the inundation from storm tide. This is fiction. There are many factors that affect storm surge. Central pressure, the lower means higher surge. The intensity in terms of the measurement of the wind, the stronger winds, the higher surge. Of course, the forward speed, the faster it's moving, the higher surge there is. The size of the hurricane is also a very important factor, and one of the ways we measure the size of a hurricane is by what we call the radius of maximum winds, or essentially how far away from the center of the storm the strongest winds in the storm are located. The angle of approach to the coastline is very important. The more perpendicular it is, the higher the surge to the right of the motion. The slope of the shoreline also has a big role. The shallower sloped coastlines, such as that in South Carolina and Georgia, can have larger surges. Finally, local features also play a big role. The concavity of coastlines, the shape of bays, how rivers interact with the ocean, headlands or islands can all have an effect on storm surge for a particular location. So let's take a look at some of the well-known hurricanes over the past 10 years and compare their strength according to the Saffir-Simpson wind scale and the damage their storm surge inflicted. Probably the biggest discrepancy in the past 10 years was Hurricane Katrina. Hurricane Katrina was only a Category 3 when it made landfall, although it was a Category 5 further out in the Gulf before landfall, but had the largest recorded storm surge in the history of the Gulf, causing catastrophic damage that was well documented in the media and continues this day to plague the New Orleans area. Some of the other storms were Hurricane Ike, which was a Category 2, but also inflicted catastrophic surge damage on the north coast of Texas. Both Hurricanes Sandy and Isaac of the past few years were only Category 1, but did extensive storm surge damage. Now, on the other end of the spectrum, you can look at a storm like Hurricane Charlie, which was a Category 4. However, its storm surge damage was only minimal to moderate, because the storm rapidly intensified just before it made landfall, not allowing the storm surge to build particularly high. On to the next statement. The highest storm surge generally occurs to the right of where the storm makes landfall. This is a fact, and let's explain a little bit. Here's a satellite image of Hurricane Hugo as it was approaching the Charleston area. Because of the counterclockwise circulation around a hurricane, the winds to the left of the track were offshore, blowing water away from the coastline, whereas the winds to the right of the track were onshore, blowing water towards the coastline. Therefore, your highest storm surge was in that portion of the storm. This next statement is important to understand. The National Weather Service can predict the specific amount of inundation from a storm tide at a given location about 48 hours before landfall. Fiction. Now, while we do issue watches 48 hours before landfall, we simply do not have the ability to give you a specific storm surge or inundation prediction at a given point 48 hours ahead of time. And I'm going to show you an example. Let's take a look at Hurricane Hugo. Its peak surge in Charleston was roughly 7.5 feet. Now, that corresponded pretty closely to the high tide. So when you combine the surge with the astronomical tidal level, you got a peak storm tide approaching 12 feet, causing tremendous inundation in the area. Now let's compare that to Gracie, which was the previous major hurricane to hit the area. The storm surge associated with Gracie was actually almost the same as Hugo, 7.5 feet. However, that surge came at a minimum in the astronomical tidal cycle. So therefore, your actual storm tide for the entire storm was much lower and caused much less damage than it did for Hugo. This next statement is important for those of you who don't live right at the coast. Inundation from a storm tide caused by a hurricane can travel 25 miles or more inland. That is a fact, especially in this part of the country. This map shows model output from a Category 5 storm hitting the coastline. As you can see, where the colors represent water above ground, it can extend all the way inland to Interstate 95 in places like Chatham, Jasper, and Beaufort counties. Other inland portions of South Carolina and Georgia are also susceptible. Here's our last statement. The largest recorded death toll from an Atlantic Ocean hurricane storm tide inundation on the east coast of the United States was recorded in South Carolina and Georgia. This is a true fact. The storm was the 1893 Sea Islands hurricane. Fatalities from storm surge were approximately 2,000 people, although estimates range from 1,000 to 2,500. Inundation is estimated to have approached 15 feet in some parts of coastal Georgia and South Carolina. It was a powerful Category 3 storm at landfall with sustained winds of 150 miles per hour. However, note that it was not a Category 5, so it could have been worse. Thank you for joining us. And hopefully we won't have to deal with any storm surge around here this year, but if we do, you should be a little bit more informed about what it is.